Creatine, the overlooked foundation of functional longevity. There is a clear paradox in today's health and longevity landscape. Never before has there been so much interest in living longer, and never before so much distraction from what truly sustains the body over time. Every week, a new compound appears, a new sophisticated name, a new promise of slowed aging. Many of these tools have value. Some can indeed offer specific benefits. The problem is not innovation itself. The problem arises when the pursuit of the new causes the basics to be ignored. At the center of this contradiction is a simple, old, inexpensive, and extensively studied compound, creatine. For decades, creatine has been associated almost exclusively with athletic performance. It became synonymous with muscle strength, gyms, and physical aesthetics. This reductionist framing pushed away a large segment of the population, especially older adults, sedentary individuals, or those who never identified with sports culture. As a result, one of the most relevant metabolic pillars of healthy aging was set aside. Today, this picture is beginning to change slowly. Some more recent discussions already acknowledge the role of creatine in cognition. Even so, it is still rarely mentioned as a true longevity strategy. And this happens because there is a fundamental misunderstanding about what actually determines how we age. Aging does not begin with a specific disease. It begins with a loss of stability. Before any diagnosis appears, the body starts to fluctuate. Energy becomes unpredictable. Recovery turns irregular. Performance varies without a clear explanation. The mind begins to falter during simple tasks. This instability, more than any isolated symptom, is the first real sign of functional aging. Creatine acts precisely at this initial point. The primary function of creatine is not to build muscle or improve immediate performance. Its central role is to support the cellular energy system. It functions as a metabolic buffer, a protective mechanism that allows the cell to respond more effectively to spikes in energy demand. And that demand increases progressively with age. As we grow older, the body begins to operate under constant stress. Metabolic stress, chronic low-grade inflammation, hormonal changes, and reduced mitochondrial efficiency. These factors continuously pressure energy production within the cell. When this production becomes unstable, the cell enters a vulnerable state. And it is in this state that persistent fatigue, loss of function, reduced adaptability, and accelerated biological aging emerge. Creatine reduces this vulnerability by increasing the availability of phosphocreatine, an energy reserve that enables the rapid regeneration of ATP, the body's primary energy currency. This does not mean creating artificial energy. It means preventing abrupt energy crashes when the system is challenged. In real life, this shows up very clearly. That feeling of exhaustion that appears in the middle of the afternoon, even without intense effort. The unexplained difficulty in starting physical activity. A workout that once felt easy now feels heavy for no obvious reason. These signs do not indicate a lack of discipline or motivation. They indicate energy instability. When creatine stores are adequate, the cell gains a margin of safety. Instead of quickly falling into deficit, it can better absorb daily stress. This reduces the excessive production of oxidative byproducts and decreases the burden on mitochondria, which naturally lose efficiency over the years. Simply put, the body begins to age with fewer internal collapses. This energy stabilization is the foundation upon which all other systems depend. Without stable energy, there is no efficient muscle contraction, no proper signaling between tissues, and no sustained cognitive clarity. Stable energy is not a detail. It is a prerequisite. It is in this context that a fundamental concept for understanding modern longevity emerges: the muscle-brain axis. For a long time, muscle was viewed only as a mechanical tissue responsible for movement and strength. Today, we know this view is incomplete. Muscle is a metabolically active organ, capable of producing and releasing substances that directly influence the brain, mood, cognition, and neurological protection. When muscle contracts efficiently, it releases signaling molecules that circulate throughout the body and reach the brain. These substances participate in processes related to memory, neural plasticity, and the maintenance of cognitive function over time. This constant dialogue between muscle and brain is one of the pillars of functional longevity. The problem is that this dialogue weakens with age. Not only because muscle mass declines, but because the remaining muscle loses energetic efficiency. It contracts less effectively, recovers more slowly, and sends weaker signals. When this happens, the brain receives fewer protective stimuli, and cognition begins to decline quietly. Creatine improves this scenario in an indirect yet profound way. By increasing the muscle's energy capacity, it allows contractions to be more efficient and consistent. Not necessarily more intense, but metabolically more stable. This improves the quality of the signal that muscle sends to the brain. This mechanism helps explain something many people notice empirically: when the body is stronger and energetically stable, mood improves, focus increases, and a sense of mental clarity becomes more frequent. This is not merely psychological. There is a real biological signal being transmitted from muscle to brain. This effect does not depend on extreme workouts. It depends on regularity and adequate energy capacity. Muscle needs to be activated consistently, not exhausted. Creatine facilitates exactly this, maintaining the quality of muscle activation over time, even when recovery is no longer as fast as it was in youth. When we observe aging through this lens, it becomes clear that longevity is not about accumulating sophisticated interventions. It is about protecting basic systems: cellular energy, communication between tissues, the ability to respond to stress. In this first block, we establish the foundation: creatine as an energy stabilizer and as a facilitator of the dialogue between muscle and brain. In the next block, we will move on to even more measurable and decisive outcomes: age-related muscle loss, bone health, silent chronic inflammation, cognitive decline in older adults, and the surprising link between creatine, biological aging, and epigenetic markers. At that point, it becomes evident that ignoring creatine when discussing longevity is not a minor oversight. It is a structural flaw in how we understand the aging process. After understanding creatine as an energy stabilizer and as a facilitator of the dialogue between muscle and brain, it becomes necessary to move forward to where aging becomes more visible and measurable. As the years pass, the body does not lose only appearance or motivation. It loses capacity. The capacity to generate strength, maintain balance, protect bones, control inflammation, and sustain cognitive function. At this point, longevity stops being an abstract concept and becomes a practical issue. One of the most striking manifestations of aging is the progressive loss of muscle mass, known as sarcopenia. It does not happen abruptly. It is slow, silent, and cumulative. Many people only notice it when simple tasks begin to require more effort, when strength declines, or when the body responds worse to exercise. This muscle loss does not affect mobility alone. It directly impacts metabolism, insulin sensitivity, balance, and the risk of falls. Muscle is one of the most metabolically active tissues in the body. When muscle mass decreases, basal metabolism drops. Blood glucose control becomes more difficult. Inflammation tends to increase. The body enters a cycle of progressive frailty. And the less muscle there is, the harder it becomes to recover it. Creatine acts decisively in this process. By increasing the capacity for energy regeneration during muscle contraction, it allows muscle to sustain training volume and stimulus intensity with less wear. This does not mean training harder, but training with higher quality. Muscle receives a more consistent signal for maintenance and growth, even at more advanced ages. In addition, creatine directly influences the cellular mechanisms involved in building muscle tissue. It does not merely improve momentary performance, it enhances the adaptive response to training. In other words, the effort invested generates greater return. This is fundamental during aging, when biological efficiency naturally declines. Preserving muscle mass is not only an aesthetic or functional matter. It is directly associated with reduced risk of falls, hospitalizations, and loss of independence. At older ages, falls represent one of the main causes of indirect mortality. Any strategy that preserves strength, balance, and reaction capacity should be understood as a longevity strategy, not merely a fitness one. This relationship extends to bone health. Bones do not strengthen in isolation. They respond to the mechanical stimulus generated by muscle. When muscle contraction is efficient and frequent, bone receives signals to maintain its density. With aging, the loss of muscle strength reduces this stimulus, accelerating bone loss. By allowing more effective and consistent muscle contractions, creatine indirectly contributes to maintaining bone health. The result is a more resilient musculoskeletal system, capable of supporting the body more safely over time. Another central element of aging is chronic low-grade inflammation. Unlike acute inflammation, which is a protective response, silent inflammation acts as a constant source of wear. It interferes with muscle function, impairs cellular signaling, accelerates cognitive decline, and increases the risk of several chronic diseases. As the years go by, the body tends to produce more oxidative byproducts, especially when energy production becomes inefficient. Overloaded mitochondria generate more oxidative stress. This stress fuels persistent inflammatory processes. Creatine helps reduce this scenario by improving energy efficiency. When the cell is able to produce energy more steadily, there is less need to activate compensatory pathways that generate oxidative stress. The result is a less inflammatory cellular environment, more favorable to preserving function. This effect is neither immediate nor dramatic. It is silent and cumulative, just like aging itself. And that is precisely why it matters. In the brain, these effects become even more evident with age. The brain is one of the most energy-dependent organs in the body. It consumes enormous amounts of ADP to maintain basic functions such as memory, attention, and information processing. With aging, neuronal energy efficiency declines. The result is memory lapses, cognitive slowing, and the persistent feeling of brain fog. Creatine contributes to increasing neural energy reserves, providing greater stability to cerebral metabolism. This does not make the brain artificially faster. It reduces vulnerability to energy dips that compromise cognitive performance. That is why the cognitive benefits of creatine tend to be more noticeable in older adults than in younger individuals. As these energy reserves are reinforced, the brain becomes more resilient. Mental clarity improves. Cognitive fatigue decreases. Information processing becomes more efficient. When sustained over time, these effects represent functional protection, not merely short-term improvement. Perhaps the most surprising aspect of creatine in the context of longevity is its relationship with biological aging. Unlike chronological age, biological aging reflects the real condition of cells and tissues. It is associated with mitochondrial function, oxidative stress, inflammation, and the stability of genetic regulatory mechanisms. The body itself uses a significant amount of metabolic resources to synthesize creatine internally. This process consumes energy and requires methyl groups, which are also needed for proper maintenance of genetic material. When creatine is obtained through diet or supplementation, the body reduces this internal demand, freeing resources for other essential processes. This metabolic relief may contribute to greater cellular stability over time. Less energy stress, less activation of pathways associated with accelerated aging, and greater preservation of functional capacity. This is not about stopping aging, but about slowing the processes that make it dysfunctional. In practical terms, this translates into something simple: maintaining capacity. The capacity to move, to think clearly, to adapt to stress, and to sustain independence. Creatine does not act as a stimulant. It acts as a silent protector of function. From a practical standpoint, using creatine does not need to be complicated. Consistency matters more than strategy. The longevity-related effects do not depend on cycling or complex protocols. They depend on maintaining adequate stores continuously, including on non-training days. Another important point is that the benefits of creatine tend to become more relevant as age advances. The greater the energy instability, the greater the impact of an efficient support system. Instead of chasing performance peaks, the focus shifts to preserving capacity over time. When we look at the whole picture, the message becomes clear. Creatine is not a shortcut. It is not a trend. It does not replace fundamental habits. But it quietly supports the systems that make those habits effective. While many longevity approaches attempt to intervene at advanced stages of decline, creatine acts earlier. It protects the foundation: cellular energy, muscle function, neural signaling, metabolic stability, and preservation of functional capacity. Ignoring creatine when discussing longevity is not merely a choice. It is an omission that compromises our understanding of aging as a functional and adaptive process. When the foundation is solid, aging becomes more predictable, more stable, and less limiting. Here, the goal is to help you understand the body's signals before they turn into problems.